Numerical number 1.6, 4-point charges QA 2 microcoulomb, QB minus 5 microcoulomb, QC 2 microcoulomb and QD minus 5 microcoulomb are located at the corners of the square ABCD of side 10 cm. What is the force on charge of 1 microcoulomb placed at the center of the square? Okay, now this I am showing you the drawing of this. Okay, here ABCD is the square and QA, that is the charge at point A, is 2 microcoulomb, QB is minus 5 microcoulomb, QC 2 microcoulomb and QD is minus 5 microcoulomb, and this plus 1 microcoulomb charge is placed at the center of the square. Now the side of the square is 10 centimeter. Okay, therefore the length of AD hypotenuse, AD, okay, according to Pythagoras rule, okay, 10 square plus 10 square becomes 200 and square root of 200 will become 10 root 2 centimeter. Okay, so distance of this plus 1 microcoulomb charge, okay, will be half of this. That is, say if you consider this point, if I show it by a different color, okay, say this point is the point O, then the distance of O point from A, B, C and D will be same, and that distance, say AO, is equal to half of this 10 root 2, and that will be 5 root 2 centimeter. Okay, so the distance of the center of the square is same from each vertices of the square, that we know from our study of geometry. Okay, now we apply the physics. Here this positive charge is placed at the center, so plus 2 microcoulomb charge here at this point A will exert repulsive force in this direction. This charge, that is 2 microcoulomb on C, will also exert the force in, that is a repulsive force, that is in the direction towards A. Okay, now the magnitude of the force on this 1 microcoulomb will be how much? Then that will be K charge at A, that is QA, charge at this point which is 1 microcoulomb, upon square of distance. The distance is 5 root 2 centimeter. So if I write this as a distance R, then it becomes R square. So both the forces are equal in magnitude. Force which is exerted by A on 1 microcoulomb and force exerted by C on this 1 microcoulomb, they are equal in magnitude and opposite in direction. Say force on 1 microcoulomb by A is Fa, and that force is towards the vertex C. Then force on 1 microcoulomb by this charge at C is, say, Fc, and that force is towards the vertex A. Both the forces are equal in magnitude and opposite in direction, so they cancel out each other's effect. Similarly, the forces which are exerted by the charges of minus 5 microcoulomb, that is on B, and minus 5 microcoulomb on D, will also exert the equal and opposite forces. Say this will be the force exerted by the charge B on this plus 1 microcoulomb charge, that is, say, force Fb. Okay, and this force will be the force exerted by the charge D, that is towards B. So these two forces are again equal and opposite, so they also cancel out each other's effect. So the resultant force on this will be equal to 0. Okay, so value of these forces can be calculated. Okay, force due to A, you can calculate force due to A is equal to K, then QA, then 1 microcoulomb charge upon the square of distance was 5 root 2 square. So if you place the value of K, 9 into 10 raised to 9, multiply by QA. Now QA is how much? 2 microcoulomb, and 1 microcoulomb is the charge which is placed at the center, that is 1 into 10 raised to minus 6, divided by square of this will become 25 2s are 50. If you simplify this, then you will get the force exerted by charge A on plus 1 microcoulomb. Similarly, force exerted by C, that will also have the same magnitude. So the force exerted by C on this plus 1 microcoulomb is same as this, that is Fc. Okay, but directions are opposite. Similarly, force exerted by D and force exerted by B, you can find. You just have to change the value here. Okay, you just have to change the value. Okay, instead of QA, the value which we have written is 2 into 10 raised to minus 6. Instead of 2 into 10 raised to minus 6, you have to write the value which is given, that is minus 5 microcoulomb. Now when minus sign is kept, then the magnitude, if you want to find, then you write 5 only, but these forces will be attractive. Okay, so the forces due to these negative charges which are there on B and D, okay, the forces which are there exerted. So the forces exerted by the charges on B and D, okay, that B and D are the two vertices on which the charges which are kept are negative, so they will exert the force on Q in such a way that Q experiences the attractive force. Now let me again show you this way. Okay, say these are the two charges which we are talking about right now. B and D are the 2 points, and minus 5 microcoulomb charge is kept here. Here also minus 5 microcoulomb charge is there. Now here this is a positive charge, so they will, or rather this positive charge will experience the force towards B. So direction of force on positive charge, that is FB, will be towards B, and this will also experience the force of attraction because of D. Okay, so direction of force on this plus Q will be towards D. Okay, so these two forces also are equal in magnitude and opposite in direction if you place the value in the formula of force. That is, force due to this B charge will be K, then Q1, say is 1 microcoulomb charge, 1 into 10 raised to minus 6, and then Q2 is say 5 microcoulomb charge, so 5 into 10 raised to minus 6, and the distance we have calculated how much it was, 5 under root 2 whole square. And if you simplify this by placing the value of K, that is 9 into 10 raised to 9, then you will get the magnitude of the force, and that magnitude of the force we got. Now the directions can be taken in this way: force due to B on this positive charge, force due to B because of this positive charge, because of this force due to B on this positive charge is towards B because it is an attractive force. Again, force due to D on this positive charge will be towards D because it is also an attractive force. So these two forces are equal in magnitude and opposite in direction, so they cancel out each other's effect. So the resultant force because of these two forces will also be 0. The resultant force because of the other two forces, that is force due to A and force due to C, okay, that is also cancelling out. Therefore the resultant force on this plus q charge which is placed on the center of this square will be equal to 0. Okay. Now we go for the another numerical, okay, 1.8. okay, 2-point charges are there, QA and QB, which are given. They are located 20 cm apart in vacuum. What is the electric force at the midpoint O of the line joining AB, okay, or O of the line joining AB, joining the two charges? Okay, so we further go for this figure. Okay, we have two charges. Okay, say for example here I am placing two charges and the magnitude of the charges, the values of the charges are given. One is 3 microcoulomb, the other one is minus 3 microcoulomb, and this is the midpoint. Okay, this is the midpoint. Distance between these two charges is 20 centimeters. So total distance is 20 centimeter. And if you consider this as a midpoint, okay, this point is A, this point as B, then AO and BO, AO is equal to BO, and that will be equal to 10 centimeter or 10 into 10 raised to minus 2 meter. Okay, we have to convert it into meter. Now we want to find out what is the electric field at the point O. Electric field here at O point we want to calculate. Now place a test charge there for a while. Say test charge is a positive charge always. So this plus 3 microcoulomb and this test charge, okay, so on test charge the force will be exerted in this direction. So direction of electric field is from left to right. Similarly, due to this minus 3 microcoulomb charge, this positive test charge will experience the attractive force. Therefore the electric field due to B will also be in the direction towards right. So both the fields are in same direction and they will be added. Okay, so the electric field due to A and electric field due to B will be the total electric field. So total electric field is E is equal to magnitude of electric field by A plus magnitude of electric field by B. Direction I have explained. It is from A to B, or we can say from left to right in this figure. Now you can easily find the formula is KQ upon R square. KQA, magnitudes only you have to write, QA upon R square. Here R will be equal to 10 centimeter for both the charges, okay, plus KQB upon R square. Now both the charges are same, distance are same, so we can generally write 2 times K. Either you take QA or QB, doesn't make any difference because magnitude of charge is same, upon R square. Okay, so you will get 5.4. If you simplify this by placing the value of K, Q you take as 3 into 10 raised to minus 6, R we have to take 10 into 10 raised to minus 2 and square of it. So you will get 5.4, okay, 5.4 into 10 to the power 6 Newton per Coulomb. This will be the intensity of electric field, and direction of electric field, as I have explained, will be from left to right or towards the charge B. This will be the direction of intensity of electric field. Okay. Now the question is that instead of this positive test charge, if we place a negative test charge, okay, then what will happen? Say first of all we place our original system of two charges at point A and point B. Okay, at point A we have positive 3 microcoulomb charge. Okay, here it is 3 microcoulomb charge, and here we have minus 3 microcoulomb charge. Okay, these are the 2 points A and B, and this is the midpoint. Okay, say O, and where we are placing another charge of the value 1.5 into 10 to the power minus 9 coulomb. Okay, now try to understand the electric field that we have calculated, and that is in which direction? That is in the direction towards right. This is the direction of electric field because of these two charges. Okay, now this charge which you are placing is a negative test charge. Okay, so this is minus 1.5 into 10 raised to minus 9 coulomb charge. So force, as you know, F is equal to QE. Okay, this is magnitude. Now if I write direction, okay, this way, so you have to first find the magnitude. So first we shall calculate the magnitude. Okay, so magnitude of the force we can find by taking the magnitude of electric field. So we can write the magnitude of charge also. So 1.5 into 10 raised to minus 9 multiply by the value of electric field, that is 5.4 into 10 raised to 6. So you will get the force exerted on this, that is magnitude of the force you will get, that is 8.1 into 10 raised to minus 3 Newton. This will be the value of the force. Okay, value of the force will be this. Now direction. Now electric field is in which direction? From left to right. Now charge which you are placing here is a negative charge. So the direction of force will be opposite to this. Okay, opposite to the direction of electric field. So the force exerted on this negative charge will be in the direction towards left. Okay, so the direction of the force on this negative test charge will be from B to A. Okay, or we can say O to A, whatever. Okay, thank you very much.